So let's talk about Kirchhoff's rules. Gustav Kirchhoff, 1824 to 1887. There's two rules for dealing with circuits. So first off, let's just deal with the electric potential difference or voltage. If I have start at this point, and let's say it has a potential of 5 volts, and then I go to here, and let's say this is 4 volts, my voltage is -1 volt. It's always V final minus V initial, which would be 4 volts minus 5 volts, which is -1 volt. So if I start at this particular point and I go this way instead and end up here, what's my voltage now? Well, it's still -1 volts. It cares about where you begin, where you end. So if I start at this 5 volts and I go around this some loop here and then end up back where I started, what's my change in potential now? Well, it would be 0. If I start and end at the same place, it is 0. So if I have a circuit, if I start here and I go all the way around and I come back to here, the total change in my potential has to be 0. If I throw some components in here, throw a resistor and a capacitor into it, if I start here, I go all the way around, I'm going to end up back in the exact same spot. I'm going to end up back with my total change is 0. So if I go across the battery, this is a negative and positive side. So that'll be the negative and positive side of the capacitor. I have some change in potential across the battery, across my power supply, minus I'm going to lose potential going across the resistor here, the change in potential across the resistor. I'm going to lose going across the capacitor, minus the change in voltage across the capacitor, and that should be 0 in the end. Now I am establishing these two numbers here to be positive numbers because I know I'm going to lose as I go across the resistor, and I'm going to lose going across from the positive to negative side of a capacitor. So I set it up so that those become positive numbers. I could have made these positive, put a plus sign in front of it, in which case these two would be negative numbers. But the total is 0 when we get to the end. This is Kirchhoff's voltage rule, or loop rule. I've seen it both ways. That the total voltage for around any loop is 0. The other rule that he has is the junction rule, Kirchhoff junction rule, or current rule. And that is as if I have a junction here, whatever current I have flowing in, so I have a certain amount of current flowing in, and then I have current flowing out. We'll call this I1 and I2. The current in is equal to the current out. Or I could also write it as all the current in minus the current out is equal to 0, however you want to word it. But at any point in a circuit, whatever current I have flowing in is equal to the current flowing out. Now, some of you at this point might go, wait a second, there's an issue here. And we will definitely address the issue at some point later in the course. It's a little bit early for that. But do recognize that suppose I have a capacitor. This is the issue that we will resolve later, hooked up to a battery. I have current flowing this way, electrons flowing the other way. So I have current flowing onto this plate, I have current flowing off this plate, but what about in between? I suddenly seem to have charge that is being stored on one plate, and then there's a gap, and then if I look at the whole thing, it fits in nicely, whatever flows in flows out. But if I look more narrowly, whatever I'm flowing in, do I have anything flowing out? And this gets into what's known as the Maxwell correction to Ampere's law, and so it is resolved. There is another type of current that is just too early in the course with which to deal right now. So we have those two rules, the junction rule and the loop rule, which ultimately allow us to solve much more complex circuit diagrams.